Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals x cubed plus 11x squared minus 25x on the interval -5 included to +5 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to apply. The first condition, the function f of x, which is x cubed plus 11x squared minus 25x, needs to be continuous on the closed interval given. X cubed plus 11x squared minus 25x is a polynomial. And a polynomial is continuous on any interval, so it will definitely be continuous on the closed interval given. Closed means that it includes both endpoints, indicated by the square brackets on both endpoints. Condition 1 is met. The second condition, the derivative, f prime of x, which will be first term, power roll, bring the power down, subtract 1 from it. Second term, power roll, bring the power down, multiply it with the 11, subtract 1 from it. Third term, constant times x, derivative is a constant. The derivative needs to be continuous, it's called differentiable, on the open interval. 3x squared plus 22x minus 25 is also a polynomial, and is therefore continuous on any interval. So this is continuous. It's called differentiable for the continuity of the derivative on the open interval. The open interval means it does not include either endpoint, indicated by the round brackets on the endpoints, because a function is never differentiable at its endpoints. Condition 2 is met. Condition 3, the function evaluated at the left endpoint f of a has to equal the function evaluated at the right endpoint f of b. In this problem, the interval is -5 to 5. A is the left endpoint, -5. B is the right endpoint, 5. We will need to evaluate f at the -5 left endpoint and f at the 5 right endpoint. Each of these are evaluated by plugging into the function. F of -5 will be -5 cubed plus 11 times -5 squared minus 25 times -5. -5 cubed is -125, plus 11 times -5 squared is a 25, and then minus 25 times a minus 5 is a positive 125. The negative 125 and the positive 125 can cancel. 11 times 25 is 275. F of 5 will be 5 cubed plus 11 times 5 squared minus 25 times 5. 5 cubed is 125, plus 11 times 5 squared is a 25, and the negative 25 times 5 is a negative 125. The 125 and the negative 125 cancel. 11 times 25 is 275. They are the same value, so f of -5 does equal f of +5. So condition 3 is met. All three conditions are met here, so Rolle's theorem does apply, which says that the slope of the tangent line at some value c equals the slope of the secant line connecting the endpoints, f of b minus f of a over b minus a. That's the result of the mean value theorem. Rolle's theorem is the special case of the mean value theorem where f of a and f of b are the same, so that this subtraction equals to 0. So that the slope of the tangent line at some value c equals to 0 for c somewhere within the open interval. There may be one c, there may be more than one c, but we're guaranteed there's at least one c in that open interval. The left side, f prime of c, is evaluated by plugging c into f prime of x. That will give 3c squared plus 22 times c minus 25, and that will equal the right side, which is a 0. We have a trinomial quadratic here, so we will need to factor this. There is no common factor between the coefficients, so we have to factor it as is. Because it's 3c squared, it'll factor into a 3c and a c. We need two numbers that multiply to be a negative 25 and add to be a positive 22 after one of them is multiplied by 3. 25 is 25 times 1 or 5 times 5. It looks like the 25 and the 1 will work if the 25 is put here and the 1 is put there, since that will give a 3c and a 25c. And that can add to be the 22 if the 25 is positive and the 3 is negative. That means we need a negative here and a positive here. Now that it's factored, each of those factors can equal 0. So 3c plus 25 equals 0, or c minus 1 equals 0. The first one, if we subtract 25 from both sides, 3c will equal negative 25, and then divide both sides by 3. c will equal negative 25 divided by 3. The second one, we add 1 to both sides, and c equals 1. Now we want to see if they end up in the interval. We're guaranteed at least one of them will, perhaps both of them will. The first one, negative 25 divided by 3. Well, negative 24 over 3 is negative 8. Negative 25 divided by 3 is more negative than negative 8 even, and so that does not end up in this interval here. It's too negative. So we do not keep this one. The second one, c equals 1, is definitely between negative 5 and 5. We will keep that one. We are guaranteed at least one, perhaps more. We ended up with just one here. There's the value of c that satisfies the conclusion of Rolle's theorem for that function.